Good afternoon, everyone. All of you are familiar with the concept of food, but I'm going to talk about food packaging today. Food packaging is as important as food itself. It protects food against external factors such as moisture and pathogens that play the most important role in food spoilage. The current plastics that we are using are synthetic plastics. They show a high moisture barrier properties, but there's a problem about them. They are not degradable. They stay in the nature for 400 years or as microplastics in the oceans, and they can cause serious problems such as cancer. So developing food packaging out of natural polymers such as whey protein and gelatin sounds like a good idea. But there's a problem about natural polymers. Natural polymers are not as good moisture barrier as synthetic plastics. So to tackle this issue, we were inspired by the nature. You know that lotus leaf has a very hydrophobic surface, and water cannot permit through it. It can only slide on its surface. So we ground lotus leaf into particles, and we tried to combine it with whey protein and gelatin. But there is another problem. Whey protein and gelatin are polar, and lotus leaf particles are non-polar, so they cannot be compatible and they cannot be combined. So to tackle this issue, we tried another thing. What would you do when you want to make a connection between two things? You use a bridge. That bridge in our work is called surfactant. Surfactant is a material which has a polar head and a non-polar tail. So it helps with make a combination between lotus leaf particles and whey protein and gelatin. And we managed to make biocomposite films out of whey protein, gelatin, and nanoparticles. Biocomposite is a material in which particles are dispersed through a continuous phase. That continuous phase, in our case, is whey protein and gelatin. By using lotus leaf particles in these biocomposite films, we managed to lower water vapor transmission rate by 76% and also increase tensile strength and flexibility to avoid breakage in terms of, in case of mechanical tension. We also added garlic oil to this biocomposite films to make antibacterial activity. And our films proved to be antibacterial resistant against Escherichia bacteria. These films were degraded in soil, tap water, deionized water, and salt water in 4 days. So these films can be used as a layer along with synthetic polymers to make biodegradability while maintaining the superior properties of these films in terms of moisture barrier properties and mechanical properties. Thank you for your attention.